before diving into classes, I just want to show you that you already know half of the story. So classes are not something completely new to you. Okay, so some of you already coded, you already implemented some programs in either C or C with C++, whatever, and you already use something which is, let's say, the predecessor of classes. And those are structures. Okay, so I will just give you a brief history of how classes have been created based on what we already knew from data structures in order to compensate with different characteristics. And if you understand the differences, you will understand the role of classes. So why do we have object-oriented programming? Okay, why we have this new paradigm? Because in the end, Linux has been written in C, let's say, and most of the compilers are written in C, and even Python. Python, it's a language, it's a new language, but the interpreter of Python is written in C. So we can actually do a lot of stuff, complex stuff like operating systems using C. So why do we need this new paradigm, the object-oriented paradigm? Why we are not happy with just functions and structures? Okay, and you will understand the idea and the reason. And then I hope you will see the advantages of classes and why those properties are actually helping us achieve those objectives. So let's start with the, let's say, the standard library, because we will print stuff to the screen, on the screen. Okay, include IOStream. And last week we played with standard. So today I will write more code than last week. So I will use this shortcut. We explain it. I will use the standard shortcut using namespace standard. Okay, and main. So why do we need object-oriented? What's the difference between what we already know and this new stuff? So before object-oriented, we were actually able to group together variables using something, let's say, you already have seen, which are called structures. So why do we need, in the first place, why do we need to group together variables? For example, let's imagine we try to build an application which will manage the data of all the students in a faculty. Okay, not the university, in the faculty. So in order to do that, obviously, let's say we need to store values like, let's say, the name of the student. So student name, I would say student name here. Okay. Again, I will always try to go for the naive approach. I will always try to avoid pointers and dynamic arrays. And in the end, I will reach a dead end. So again, I will give you reasons why you should embrace, let's say, dynamic arrays and pointers. So generally, I will try to find a way without pointers and dynamic arrays. And in many cases, you will see that will lead me to a dead end. So don't do my mistakes, go for dynamic arrays. So in this case, let's suppose the student name is only 100 characters at most, which I think will cope with many of our names. Okay, and here I will have age, the age of the student. Okay, and what else? So for example, let's also introduce a boolean. So bool. And let's say if this student has a scholarship, okay, so has scholarship. You see, remember we talked about naming convention, scholarship. And I told you that we will use mixed camel case. And you see, for booleans, because boolean, remember, it's either true or false. And when you define an attribute or a property of something, generally true or false means that entity has something or doesn't have, or is, so has something or is something. Okay, so in this case, I'm using the boolean in order to say if the student has a scholarship or not. Okay, so that's why I'm using has. And generally, boolean variables should be defined starting with has or is. So always say something about the meaning of that. And I think it's very direct, the objective of this variable, to actually say if the student has a scholarship or not. Okay, So student name, age, scholarship. Okay, now if I have 1,000 students and I want to do this with arrays, so you see here I have three variables which can manage the data of only one student. So this is it. This program will always manage only one student, right? The student name, the student age, and has scholarship. Again, here, regarding naming conventions, here you may say, hey, this age is associated with what? The student or the professor or whatever. So here I should also say student age if I want to be consistent, okay, to have the same pattern for all the attributes. Okay, so having these three variables, I can manage only the data of a single student. So how can I handle data for 1,000 students? Let's suppose I don't know about data structures. So in order to manage the data for 1,000 students, so let's say this is data for only one student, okay? If I want to manage data for, let's say, 1,000 students, okay, I will go for arrays. So I will define here what? An array of 1,000 names, okay, because I want to manage 1,000 students. So let's define the number here. Number of students equals 1,000. Okay, so I will know I have 1,000 students. And now I will define an array of 1,000 arrays which are representing the name. So how can I define an array of 1,000 arrays of names? Always start with the name. So let's say student names. So how many of them? 1,000. And now it will ask you what's this type of all the values here in this 1,000 array of elements. And remember, the type goes here. So what's the type there? At this point, you may say, hey, it's a char array of 100. Okay, so we know we can't actually do this because when you define arrays, C and C++, they have this strange way of not allowing us to put the brackets here. They just ask the brackets here after the variable name, which is a nonsense because this is actually the type. This is part of the type. You see, if you take the name pattern for variables, remember we have type, variable name. But what's this here? Because naturally this should go here because this is a char of one. This is an array of 100 chars, and this is the variable name, the student name. But you see, C and C++, they use this as an exception. So when we define arrays, there is an exception. You don't go for the classic pattern. No, you set the type of the element here, you put the variable name, and here the number of elements. But if you think at this logically, this is actually part of the type. Okay, so in that case, I can define it here. So we have what? 1,000 lines, each line having 100 characters. So you may say, hey, this is a matrix. Yeah, exactly. This is a matrix. Okay, it's a matrix with 1,000 lines and 100 columns because each line has 100 columns. Okay, we can define it like this. Now, if you don't want to see it as a matrix and you want to see it as an array of strings, because remember, all names for arrays are actually pointers to that array. So student name is actually a pointer. You see, now I need to build this one. If I hover the mouse, it's saying that the student name is 100, but if I do a function to print it, it will see it as a pointer to a char. So student name is actually a pointer to the first char here in this array of 100 chars. So let's avoid the matrix and I can define it like this. Okay, so let's leave both definitions. So it can go like this. Okay, if you like to play with the matrix, or we can leave it like this. So in this case, you see, we have an array of 1,000 pointers to chars, and each pointer to a char is actually managing a name by itself. Okay, so I can go like that. And for student age, again, this looks like this. Student age is 1,000. Okay, I can use number of students here, but there is only one condition. remember when we define static arrays, they are created on the function stack. So every time I define a static array, this will be created on the function stack. So in order for the compiler to know for sure what's the size of the function stack, the compiler wants to know for sure what's the size of the static array. So if you try to put here number of students as the variable, it will give you a compiler error, and it's very explicit. So the compiler is saying, hey, I know that you can actually change this variable at any moment. So after this line, you will write number of students equals 10, and you can do that with any variable. And because you can do that, in that case, this array will be inconsistent. So this is like you created the array with 1000 values, and after that you change number of students, which is not fair because this static array should have a fixed size. Okay, so here you create the impression that you are actually resizing the array. So in order to use variables here for sizes of static arrays, you see the error, it's very explicit. Expression must have a constant value. Okay, which means, hey, I will accept a variable here if you sign this contract, and on this contract you promise that you will never change number of students. So they will be in this one-to-one relation forever till the end of the program. Okay, so you can use variables here, but you need to define them constant. Okay, so that's why here, let's say I'm writing 1000, or yeah, I can go for const. The code looks much more prettier, let's say. Okay, so this will be the array of student ages. And obviously for bool, I will have an array with 1000 Boolean values. So here I will say student scholarships. Okay, number of students. Again, it's a constant, so I can't change it anymore. You see, if I try to say number of students equals 10, it will not allow me. It will say, hey, this expression must be a modifiable left value, which means you can't change it because it's constant. Okay, so in this way, we can manage the data for 1000 students. Now, just to show you that this will lead to a dead end. Remember, I will try to go for static arrays, avoiding dynamic arrays and pointers, but generally I will hit a wall because that road is a dead end. Why? What will happen if you realize that in the faculty there are 1001 students? What do you need to do? So you develop this application, you implement it in the faculty, and after 1 month, the secretary will go to you and say, hey, we reached the maximum students, and in the faculty there are 1001 students. So what do? You try to expel some of them? No. So you need to go back to the source code and you will change this to 1001. And now you recompile, you send the data, you send the application back to the faculty. And you see, this can develop in a, let's say, in a bad joke. After 1 week, the number will be 1002. At some point, you will say, hey, I will not increment this each week. So let's double the size. But what will happen in 5 years? Okay, this size will be reached, and so on. So this is the issue with static arrays. They are limited. Okay, at some point, they will reach their limit. Okay, so that's why you should use dynamic arrays. Okay, so in this way, without knowing about data structures, I can actually store data not just for just one student, I can store it for multiple students. So the issue here will be to keep these 3 arrays synchronized. What means? It means that the name of the first student, so the value at student names index 0, should be the equivalent of the student ages index 0 and also the student scholarship at index 0. So every time you add a new student or you change the student data, you need to keep all 3 arrays synchronized, okay? Because on the same location, on those 3 arrays, you actually have the data for one student from those 1000. And that's not quite easy because you see, every time you need to manage 3 arrays. And remember, humans are very bad and at managing a lot of stuff in the same time. That's why we build computers, okay, to do that for us. So generally, you should try to keep the program as simple as possible. So instead of having 3 arrays, I think it's much more easy to manage only 1 array instead of 3 arrays. Okay, so how can I store all the data in only 1 array? So at this point, we were using a very interesting concept, which was called data structure, in order to group together these 3 variables as one. Because otherwise, you see, I just need to define a lot of arrays for each attribute and so on and so on. So data structures solve this issue, how to manage data for multiple entities, which have, let's say, a description based on multiple properties or attributes. So instead of doing this stuff, and at some point I will do a mistake here with all these 3 arrays. So we were using structures. So here I will say, this is the student structure. Again, in the mixed camel case naming convention, all our class names will be written with caps. Okay, so all the class names will be written with the caps. Functions and variables will start with the lowercase, but the class names will start with the capital one. So I will group together these 3 variables. Okay, so when I will say student, and actually I will define, so with data structures, and I will define a single variable. So let's say student. Actually, by this single variable, I can manage multiple attributes, 3, 4, 5, depending on how many you define here. So this was the big advantage of data structures. They are bringing together multiple variables which were describing the same entity. Regarding naming conventions, you see, we are in the student entity. So here I have student name, student age. Yeah, but this is redundant, right? So this is like saying, hey, in the student entity, you have the whatever professor name. So in that case, I don't need to repeat student, because now they are all related to the structure. So here I will have age, name, age, and has scholarship. Okay, so this was the power of data structures. So again, here I have a single variable, you see, instead of 3 to manage the data for only 1 student. How can I manage an array of 1,000 students? Is it simpler with data structures? So if I want to define an array of students, okay, number of students, where is number of students? Number of students. Then now I resolved again this complex problem, because managing the data for 1,000 students with data structures requires only 1 array. So you see, I don't have this issue here. How do I store the names? How do I define that array of names, either like a matrix or an array of pointers to char, whatever. So things are, again, simple. So I need only 1 variable to manage data for 1,000 students. And this was the power of data structures. Okay, so some of you or all of you, you already knew that. So the question is, why this is not sufficient? Why we have a new paradigm? Why do we have object-oriented? So let's see what are the limitations of data structures, and then you'll understand why we have object-oriented programming. So how do we define here, for example, a function which will initialize the data of a student? So how could I do that? Okay, to write a function that will init the data of a student. So I will write, and remember, when you define a function, you just need to cover 4 things. So always start, and this is not when you define a function. Every time you do something, always start with what you know. Start with the easy stuff. Even if you need to do a complex, I don't know, algorithm, always split that algorithm in small pieces. Okay, break it into small pieces that you actually know how to do. Okay, always do that. So what's the easiest thing about defining a function? The name. So I will start with this one, init student or initialize student or whatever. So I will initialize the student here. The second question is, what do we need in order to initialize the student? So what data do we need? So let's say, what's a student? It has a name, it has an age, and it has a scholarship. So this is the stuff that I will need in order to initialize a student. So let's ask for the name. And again, here I will say name. And you see, even if I know that the name has 100 characters, I will not write here 100. Why? Because sometimes maybe I will get a smaller name. Who knows? So why to limit myself to only exactly 100 characters? Because I can accept less. So generally, I will define my, let's say, my arrays like this, okay? Char name without values here, or actually, in reality, this is a pointer to a char. Remember, all the array names are actually pointers to the first value there. So name is actually, let's write it here, is a char asterisk. Let's say name, sorry, name is a char asterisk. And if I go here and ask this, hey, what's students? Students is a pointer to the first student in this array. So students, the variable students is a pointer to the first student. So how do we define a pointer to a student? Is student asterisk. Remember this, all array names are pointers to the first value, all of them. There is no exception. So either you define the char array like this, char name with empty brackets, or you can say like this, okay, char name. So it's the same. I will mix them from time to time, but generally, let's say I like more this one because I have your experience. When I was a student, I didn't like pointers when I saw them for the first time. So it's still haunting me, those bad memories. Okay, so I need the name, I need the age, and here I need to know if the student has a scholarship. Okay, so has scholarship. Okay. Now, the third question is, what do we need to return? So do we need to return something? What's the scope of this function? Always go back to what's the scope. The scope of the function is to create a student and to return it. Great. So what this function will return? A student, right? So this function will return a student. Okay. And that's the name, init student. So let's init the student. So I will say here, student. So at this point, I'm creating an empty student, an empty in terms of it doesn't have any values. And actually, all its attributes at this point, they have default values. So what will be the default value for name? What do you think? So I will have an array of 100 characters, and each character will be what?
Would be 0, right?
Will be 0, or anyone else?
Null.
Null. Great. It's 0. So I got an answer 0. I got null. So the question was, what will be the default values for all 100 characters here in name? So 0, null. Anyone else? Okay.
Oh, it's null pointer.
No,
null
it's just a char. It's just a char. Okay.
Yeah,
So,
but it's yeah. Okay.
So the question is, what's the default value for all those 100 characters? Because the pointer name gets the address of this static array. So name will have an address because this is a static array, will be created. The question was, what are the values for all those 100 characters? Okay, so I have 0 and null. I don't know which is the correct answer. Let's see. Let's say at this moment, we all believe it's either 0 or null. Okay, so which will be the default value for age? So all those 100 characters will have 0 or null. For age, what do you think?
Actually, it's all of it. It's gibberish. Like now that I think about it, yeah, we can't know. Neither for name, age, or high scholarship.
Okay, that's great. So if I do a resume, some of you will think we might get 0, okay, which is null. So 0 null is the same, 0. And some of you think that we will have here some, I don't know, strange values, residual data, right? So we are two teams at this point. Okay, agree with you. So student, it will have an age and also for a scholarship for the Boolean. So what do we want to do? We want to copy the values from here into the student, right? So how do I access the attributes of a student? We know this from structures. You just go for the name of the article, and this is called an article. For classes, they are called objects, but a variable of a structure type, it's called an article. So let's say this is an article or an element, whatever. It's a student. So in order to access its attributes, you see, I can use the dot operator. So here the IntelliSense is saying, okay, what do you want to access from that student? Which actually means what do you want to access from that collection of variables? Because student is actually a collection of 3 variables. That's the idea of a data structure. Okay, so I will say, hey, let's start with age equals age. After that, I will say student dot has scholarship equals has scholarship. Okay, and the last one will be student name equals name. And now again, our friend compiler will say, no, you can't do that, because you see, expression must be a modifiable left value, which means the variable to the left of equals, that's why it's called the L value, left value, should allow us to change its value. So which is the variable that we want to change? Now, you may say the student is, because we see the student name highlighted with red, okay, underlined with red, but actually we don't want to change the student, we change the name, right? This is the student dot name. So the error is about the name, and actually saying, hey, the name from that student should be a modifiable left value, which means this variable here is not modifiable. But remember, this is just the pointer. So actually, all pointers to static arrays are not modifiable, which means once you define this array, this pointer will stick. It's like it has a tattoo, okay? It's saying, this is my address. So the address of this, the value of this pointer will be forever, and you can't change it because it's constant, will be forever pointing to this array, to the address of this array of 100 characters. And the same story is for this array, and this array. You see the second limitation of static arrays for today. Once you created them, you can't change them. So this array will, this pointer student ages will point forever to this array of 1000 integers. So you can't say later, hey, we need an array of 2000 integers. So let's make this pointer to point to a new array of 2000 integers. You can't change this one. You see, if I try to do this later and say, hey, the secretary has said to me that now we have more than 1000 students in the faculty. So let's try to allocate a new array of double the size, number of students. We can't do this, number of students, because you will see the same error. Expression must be a modifiable left value. Okay, so again, these pointers are constant. Once you define them, you stick with them till the end. Okay, you can't change that pointer to another array. Okay, so we can't actually change the address of this pointer to point to the name which we receive here, which in the end, it's a good thing, because here we should remember that if you want to copy a char array content from a source to a destination, we don't use equals. And for that, we have, let's say, functions which have been created, implemented just to help us do that. So how do we copy a char array from this variable to this variable inside the student? Remember string copy, which is another C function. So string copy, what's the destination? Student.name and the source is the name that we receive here. Okay, so if I try to do a build rebuild, okay, I have a compiler error saying string copy is unsafe. Okay, because someone here can provide us a name which is bigger than 100 characters. So right now they are forcing us to use the safest version of string copy, which is string copy underscore s. And now string copy underscore s, and that's the difference between string copy, the classic string copy, and this one with underscore s, is that this one will check the size of the destination, and you see it's a static array of 100 characters, and it will copy from name only 100 characters. Okay, so if you pass here a name longer than 100 characters, string copy underscore s will copy only the first 100. String copy, the classic string copy without underscore s, would copy all the name that you get from here. And remember the discussion we had last week with the function stack, and 2 weeks ago, it will override other variables. Because if you have this array of 100 characters and I'm giving you here 200 characters, which means 200 bytes, the classic string copy will copy all 200. So they will fill this array of 100 bytes, and the other 100 bytes will override all the other variables which are in memory following the name. So that's why it was very dangerous. And that's why now we are using underscore s. Okay, so we copy names or char arrays with string copy, not with equals. Okay, doesn't work, does not work. Okay, for strings or for char arrays. Okay, so now we know how to copy. So you have the student age, has scholarship, string copy, student name. Super. So let's test this function. And before that, let's return the student, because we need to return the student. Okay, this is our contract. This is what we said. We will return a student. So return student. And in order to test the function, obviously we need to print the student, right? So let's print it. I will write another function, print student, or print student data, whatever. Again, I will start with the easy stuff, the name of the function. I think it's obvious what the function will do, will print a student. And now the second question is, what do you need to print a student? And again, the answer should be obvious. You need a student to print a student. Okay. And what this function should return. So this function does not return anything because it will just print to the console. So in that case, the function returns void. Okay, so always approach functions like this. Okay, just go through this logic sequence. Okay, start with the name, ask yourself, what do you need? And after that, ask, what do you need to return? And after that, just dive into the body of the function. So let's print the student data. So I will say cout end line student name. Okay, and here I will say student dot name. Okay, after that I will say age. Okay, and the last one, if has a scholarship. Now, if we print the scholarship, we know that for booleans the value is true or false, but we also know that in C and C++, all the values which are actually different than 0 are considered to be true, and false is 0. So this will be interesting. So let's see how we will actually see the boolean generally. So let's try to say something here, has scholarship. So I want to see if the student has scholarship. Obviously I will want to see true or false, right? Because then the secretary can actually read the message. But it's interesting to see what will actually happen, and we will fix it. Okay, so this is a very short example of a program which will manage students' data, and we are using data structures. And I hope it's clear why we need data structures, because otherwise you need to play with a lot of variables here, which is, yeah, it will be quite difficult. So here it's much more easier. Okay, so let's test this one. I have the student here. So let's initialize it. So I will say student equals init student. And now again, always use the IntelliSense. Don't play this game. Scroll up, scroll down, scroll up, scroll down, because your program will have many functions. So generally you will forget what's the sequence of arguments. And generally some of you, I see that also at the exam, you just scroll up, scroll down, scroll up, scroll down. And sometimes I believe that it's I don't know, it's a technique to hypnotize the evaluator like me. So you just scroll up, scroll down, and maybe I will get fall into a deep sleep, and yeah, you pass the exam, which generally never happens. And the effect is quite the opposite, because this is quite annoying. So just scroll up, scroll down, and generally, yeah, the level of nervosity is just increasing. So don't do that. Don't scroll up and scroll down. Open the IntelliSense. Okay, so if the IntelliSense is gone, just press Control Space or just delete the one bracket and write it again. So check this. Okay, that's why you don't need to scroll up and down. So what do we need? We need a name, age, and the Boolean. So for name, let's say this is John. For age, again, you see the IntelliSense is following me and it's showing me what I need to write. So age is, let's say 21, and has scholarship. Yes, it has scholarship, true. Okay, and now we have an issue here. So let's build rebuild again, just to be sure. And I have a compiler error here, which is also visible here. And it's saying argument of type const char asterisk. So every time you see argument of type, remember argument refers to these values here. So these are the values that you pass when you call the function. These are called arguments, okay? And let's read the error. Argument of type const char asterisk is incompatible with parameter of type char asterisk. So if we want to speak like a pro, it means that these here are called parameters. So when you define the function, this is called the parameter. This is parameter name, age, and has scholarship. And when you call the function, when you use it and you pass some values, these are called arguments. Okay, so we learn how to speak by just reading the compiler errors. So what it's saying is saying that here we have an argument of const char asterisk, which is incompatible with a parameter of type char asterisk. So which is our parameter char asterisk? And we know it's the name, and you see it's already highlighted, which means that John between double quotes is actually a constant pointer to a char. And if I go back here to the function definition, you see name, it's a char asterisk. Like I said, all arrays are pointers to the first element in that array. So what's the issue with the compiler now? I explained this in more detail with your colleagues yesterday during the laboratories, and you will have the recording. So if we don't do the laboratories together, and if you have, let's say 1 hour and a half, 2 hours, just go through the other recordings. Maybe you will find out new stuff, or maybe I will highlight things that you already knew, but maybe you forgot them. So if you have spare time, just go through them. Okay. So the short explanation is that this array does not exist in memory. Okay. So this is a hard-coded array. It exists only in the source code. And when this program will be compiled, that array will be inserted into the machine code. That's why they are called hard-coded strings. So they will exist in the machine code. If you check the exe, we will see John there in the exe file. Okay, and because this is an array which does not exist in memory, it means that we can't actually change it. So we can't actually change the first letter to another value, because this array is just is like a label. It's just a value. It doesn't have a representation in memory. And for that, in order to stop us to actually change it, then it will always be seen as a constant array. So it's always seen as a constant array of chars. Okay. And that's why our function here, you see it's receiving a name. And from this definition, it means we can actually change the name. So if I do this, no one will stop me. Name 0 equals Z. Why do I do this? I don't know, because I want it and I can. So because of this reason, the compiler will say, hey, I can't give you a constant array to a function. I can't allow you to do this, to pass here a constant array to a function which has the power to change anything there. So you need to assure me that you will never change that array, because in that case, I will never allow you to do this. So we have two options right now. We either make this to be an array in memory. So in order to make it an array in memory, I will do this: char initial name equals John. And now the compiler will create, and this is obviously either like this or with char asterisk. And now this is actually a static array. You see, when I hover the mouse over it, it's saying const char 5. Why 5? Because you have JOHN, 4 letters, and \0. Don't forget \0. So that's why you have 5 bytes. Okay, we see 4, but there are 5 bytes there. \0 at the end. So when I define this, now we are actually creating an array on the main stack with this value. So now I can pass this variable here. And now I can change it. So if I want to change J into Z, now I can do it, because this is something in memory. It's an array in memory on the function on the main stack, which I can change it. Okay, so this is the first solution. Now, some of you will say, yeah, but I will have a lot of, I don't know, predefined names. So for each one, I will define an array. No, let's go back to init student. So let's ask the real question. Hey, is normal to do this here in init student? Is normal to change this name? Now, if you want to change a name, change the student name. But why are you changing this input variable? It makes no sense. And this is actually considered to be a nonsense. And this could be a mistake. It could be a logic bug. Someone write this here. It doesn't, is not aware about the mistake. And now you are wondering why all your names start with capital Z. So the second approach, and I will always go for this approach, is to make a clear distinction between input variables and output variables. So in this case, I don't want to allow me or others, programmers, to actually change the name here. And if you actually now you realize that, hey, these are only for input, and it's not normal that someone will write this by mistake. Again, you see, I'm changing the received age. So here you call me with 21. Here I make it 100. And after that, you ask yourself why this student John has the age 100. And you pass it here 21. You see, these are the real bugs, which are difficult to find. So in order to prevent this kind of stuff, now I think it makes sense that every time you pass an input variable, which has only one scope, to be input, okay, to just give your value, and you have no reason to change it, to pass, to define all these values with const. Because in this way, you prevent mistakes. By mistake, you will say has scholarship equals false, by mistake. Now, if you try to do this now, by mistake, you see, expression must be a modifier left value. And now you say, oh, sorry. Yeah, not you. I was referring to the student one. Okay, which is a different story. Okay, and yeah, student is defined later. But this is the way we should think when you define functions. And this is the way we should actually use const. Okay, for functions, in order to prevent anyone to change those variables if there is no reason to change them. And these kind of mistakes are happening. So this is the way you are actually starting to understand coding. Okay, so this is actually programming. You see, you need to be aware of the details. And this is the level of programming that you need to reach, okay, to write code which is safe, which prevents mistakes of different programmers and so on and so on. Okay, and you see how the compiler it's actually guiding us towards this kind of stuff. Everything started here when we tried to call John, and the discussion we have now is because John is here constant, and we actually realized, hey, yeah, all this should be constant. Okay, now Generally, I will try to code like this, okay, to define all these variables const.
What
So
if we put an asterisk on the char, like on the
here,
parameters? Yes, instead of const.
so instead of const, I will write here
Yeah.
char asterisk.
Yeah.
Okay.
Mm.
So this is an array of pointers to char. So this is actually an array of arrays. So
Okay.
const is referring to the content of that variable. So at this point, you see, I can apply const to an integer. I can apply const to a Boolean. And here I want to apply const, not to the char. Remember in C, I don't know why they made this decision, but it's wrong. This is actually the type. This is a name. It's a char array, right? But in C and C++, we put the brackets here. But the brackets are actually part of the type. Do you agree with me? That,
Yeah.
Yeah, please.
Yes, I agree
Okay.
with you.
Okay. So this is not actually a single char. You need to also add the brackets in your mind. So const is actually referring, has no relation with a char array or an int or a bool. No, const is just const. It can be applied to anything. And const means that that variable, no matter its type, should have a constant content. Okay? So if I write it like this, sorry.
Can I ask something related to this?
Yeah. But I'm barely hearing you. So
It's better now?
yeah, kind of. So I'm listening.
So what if we just modify the parameter and ask for a char star name without having a static array?
So
char,
like this, char asterisk name.
Yes, exactly. And instead of giving as an argument a constant variable, we can just leave it as it is, right?
So here,
if we delete the first line, that one is.
So here
yes.
I will write initial name.
No,
or leave it like this.
We leave it like this.
Okay.
We delete the text on line 46.
Okay.
And as a parameter, we have char asterisk name.
So here we have char asterisk name. Okay.
Yes.
So this is the combination. Okay. What will happen now? That's the question. Okay. So there is no difference between char asterisk name and char name with empty brackets, with empty, without a value here. So this is the first thing that we need to synchronize. So char asterisk is the same. It's an alias for writing char with empty brackets, without a value. Okay, so they will always be the same. That's why I prefer this one, because actually it's char asterisk. So it's the same. Now, this is different of this when you write the size. When you write the size here, if I write the size here 100, this is again a pointer to a char, but now the array, it's a static one of 100 elements. Okay, so even if I write char asterisk here, or char name without a size, is the same. Okay, it's just another way of writing stuff. Now, if I go back here, you see I have the same error. Because again, even if you pass me a pointer to a char, this is a normal pointer to a char, which means I can actually change everything in that array. Okay, so if I write name at index 0 equals Z, I can change it. And this is what the compiler is trying to tell us. Hey, here I'm giving you a constant array of chars, which means you can't change John in any way. And you are passing this value to a function which has the power to actually change it. Okay, so remember, when you write a hard-coded string like this value does not exist in memory. So this is like trying to do this. John at index 0 equals Z. Okay, can we do this? No, because this should be a variable in memory. This is just a value, and this value does not exist in memory. And that's why by default, all hard-coded strings are constant arrays of chars. Okay, so if you want to use them, this is the idea. If you want to use this kind of approach and you don't want to define an array of characters each time you want to use a predefined value, so if you want to use this directly, you need to assure the compiler that this function will never try to change this. So how do we assure it? By saying here that this char array is constant. You see, because if I try to change it, now it's saying, yeah, but this is the contract. You sign it. You are saying that you will never change this array. Okay? So this is the conclusion. If you want to use hard-coded strings or arrays, char arrays, you need to assure the compiler that you will never try to change it. And I extended the idea by making a clear distinction between parameters which are just for input, and it makes no sense to change age or scholarship here. So that's why I think we should define every time we have input parameters which are not going to change, constant. So constant should be something we should use many times, because this will prevent us from making mistakes here. Okay, not just for strings. Okay, I hope I clarified. So if it's still not clear, you need to give me a hint. Okay. Okay, so let's continue. Let's see. Break. Okay. So yeah, before taking the break, let's print it. So let's print the student, and let's see if what your colleague said when we started about the default values is true. So let's print the student and take the break. So print student. Okay, build, rebuild. Okay, and debug, start without debugging. And here it is. So here I have student name John, student age 21, has scholarship 1. So you see, I don't like this one because let's say the secretary will want to see here true or false. So we will fix this one. And I see the values that we passed. So how do we check which were the default values for the student? We need to print the student before we initialize it. So let's print this one and take the break. So print, sorry, not printf, print student of student. Okay, so build, rebuild. And okay, fortunately, the compiler is preventing us to do this. It's saying uninitialized local variable student used. Okay, and the error is here. Okay, so we can't actually use it directly. So we still have this question: what are the default values for a student? But after the break, we will use the debugger to actually see which are the default values for student. Okay, so we can't use it, but the debugger will show us which are the defaults here. Okay. So let's answer to those questions. So the first one, how do we make here to print the student scholarship with true or false? Because you see, for true is 1, and you can imagine that for false will be 0, which, generally we want to print true or false. So in order to do that, obviously here we need to write something which will transform the true or false into 2 strings, either true or false. And if you have a very short if then else, then you can actually use the conditional operator or the ternary operator. I think some of you know it by this name. And this operator looks like this. So generally, I will try to do this. So here I will write as a comment just to help you remember this operator, because again, we will use it. So this goes like this. If student has scholarship, and you see, at this point, some of you will try to say equals true or equals false. Yeah, but this is a Boolean. And you see the name has scholarship, which means if this variable is true, it means the student has scholarship. So generally it's redundant and it's not okay to check a Boolean if it's true or not. Okay, so don't do that because this is actually a Boolean. It's true or false. So if you say if student has scholarship, and now you see the advantage of naming these attributes with has or is, it's very easy to read what you are testing here. So if student has scholarship, then you will try to say true to return this one, else you want to say, hey, false, okay, to return a string. So, or anything else. Here you can say it has scholarship or it doesn't have a scholarship and so on. So this could be what we try to do here with the ternary or conditional operator. So the operator looks like this. You ask the question, the brackets are not necessary. So here I will say if student has scholarship question mark. So this is actually the if. Again, here you can actually write equals true or false, but again, don't do this for Booleans. Okay, only juniors do this, so don't be a junior. Okay, and here you have has scholarship question mark, and now what do we want to return? So this is like an expression. So what do you want for this expression to return? So here I want to return true, the string true. Yeah. Or false. Or anything else. So don't think that you should always return true or false as strings. No, this is my option now. Okay, so yeah, it's a coincidence.
But why does it return like this? At first I thought that you would cast it or something like that, but it's already a bool. So I don't know why is it shown as an integer and not as a bool.
Because
like
this is the C and C++ compiler. Okay, in Java, maybe they had the same question as you right now. So when they design Java, they are printing true or false, and in .NET the same. Okay, this is the compiler. So this is the way the C and C++ compiler is converting by default a Boolean into numbers, into a string actually, because they are actually returning actually this. You see, they are returning the string with 1. You see it as a number, but it's actually a string that ends 0. Okay, so it's converting the number. This is the language. That's it. So yeah, they changed that in Java and .NET because as you observe now, many others said, hey, why we don't see true or false? Now, that was the decision they made. Okay, so that's why we need to actually do an if and to return something here that will have a meaning for true or false. And this is the fastest way, because otherwise, you see here, if you go for an if, you should have here a char array. You should define a variable, that variable equals true, or that variable equals false. So here you actually need to write a lot of code just to convert your Boolean to a string. But using the conditional operator, it's faster. So that's why we will use it many times, especially for Booleans. Okay, so this one will fix the display. So let's rebuild, start without debugging. Let's see that, start without debugging. Okay, and now I can see it here. So has scholarship 1. Whoa, wait a minute. Whoa. What's our mistake? So print student build rebuild. I'm running the same app. I still see 1. Let's run it again. Start without debugging. Okay, and I still see 1. Okay, 1 second. Let's check what's happening here. I'm still seeing 1. And I think, yeah, this is the precedence of operators. So it's actually taking this value, and after that is trying to apply the conditional operator. So in C, let's put them between brackets. Let's see if this fixes the problems, because it took the same value from here. So build rebuild. we need to force to execute the conditional operator, and after that the output stream. Debug start without debugging, and now we can actually see it. Okay, so has scholarship true or false depending on what's the value there. Okay, so yeah, just place it between brackets. So the second question was, what's the default value of the student attributes? And some of you said 0. After that, we got another answer, some default values or whatever. So let's put a breakpoint here, or right after the student has been initialized or created. So again, build, rebuild, and now I will start with debugger because I want to stop here. So debug, start debugging, F5. Okay, so the code stopped here. Why it didn't stop there? At least, okay, it stopped here on student equals init student. So it didn't execute this line here. Again, I see locals, autos, watch one. Locals means all the local variables to main. So if you don't see these 3 windows, you can go here, debug windows, and here they are, watch, autos, locals. So you can activate them from here. So let's check student, but I can also check student if I hover the mouse over it. So if I hover the mouse over it, I see this value, which is a strange symbol, but I see it for all 100 characters. So it's the same value. For age, I see -858. Okay. And has scholarship, you see, I see by default true. Why? Because again, it gets this value, and remember, if it's not 0, any number, it's true. It's the equivalent of true. So what's this value? So let's answer to the question. What's the default value of all our variables in C++ using the Microsoft Visual Studio compiler? So if we were on Linux, by default, you get 0. So any of you who are coding on a Linux machine using a CLang compiler or a GCC GNU C compiler, or you are coding on a Mac and you are using, again, Mac is based on a Linux. So you are not using the C compiler from Microsoft Visual Studio, you will get 0. And by default, 0 is false. So for Boolean, you get false. But for the rest of us, which are using the Microsoft Visual Studio compiler, we will always get this very strange value. And remember that here you can actually switch and see all these values in hexa. So let's see them in hexa. And in order to do that, just click anywhere here and check this option, hexadecimal display. And you see, if now I hover again, age is 0xccccc, has scholarship again is 0xcc. And if you actually check all the values here in this array in name, you see each character, that strange symbol is 0xcc. Now, my question to you is, why for age do you see, if you count them, 8 C's? And why for has scholarship or for a char here, you see only CC? So why for age we see 8 symbols C, and why for has scholarship only 2? And
well,
for
it's because of the each variables, each data types space in memory.
exactly.
So we have 2
yeah.
C's for 1 byte.
Exactly.
8 for 4, and so on and so
because
forth.
this is in hexa, so
Yeah.
this is a value of a single byte, and you see actually a Boolean in memory requires how many bytes? 1. Okay, yeah. So even if we use only 1 and 0, true or false, actually it needs 1 byte because that's the minimum amount of data that we can play with. And you see for name, all the characters, because they're a char, a byte, again, they have 0xcc. So what's the default value that we will always get for everything in Visual Studio using the Microsoft compiler? 0xcc for each byte. And here they are. You see the screen is full with 0xcc's because we have a lot of data which is uninitialized. So in Visual Studio, this is what we get, 0xcc. And for heap, you will see they are giving us CD, the hexa CD, CD, CD for each byte. Okay. Now, I don't know why they choose this value, but this is it. So you don't get 0 by default, not here. At least not for this version. Maybe in 2022, Visual Studio 22, maybe they change this and you get 0 by default, but not in this version of Visual Studio. Okay, so these were the answers to those questions, which are the defaults. Now, you see, fortunately, it's not allowing us to print the student, but if we could print the student, you will see strange symbols for name. And if you see them, it's because you get by default 0xCCC. But fortunately, here the compiler actually realizes that student is not initialized and is not allowing us to do that. But after we initialize it, it's okay. But sometimes we will succeed in printing data which is uninitialized, and you will see very strange values. Okay. So let's go back to the structures versus classes. So what's wrong with this program? What's wrong with this? This is what's wrong. And that's why we have the new paradigm, the object-oriented paradigm. What will happen if here we realize that, hey, we forgot about the student grades? So let's imagine we build this solution. So we work on this for months. We deliver to the faculty, they will enroll all the students, they will store the data of all the students. And now you get a call and the secretary will say, hey, grade up, we just recorded the data for our, I don't know, thousands of students we have. But can you tell us where do we insert the grades? Because school started and now they had some exams. So where do we store the grades? Oops, we forgot about them. So change, and you know, it's a famous quote from Einstein, I think, that the change, it's not from Einstein, it's quite older, from Aristotle. I need to look that up. But the quote says like this: the change is the only constant in universe, because everything is changing and we are living this daily as a proof. So software is not, let's say, protected by change. Actually, change, it's again omnipresent in software, because clients will always want more. You will always find new ways to improve the solution. So at this point, you spend months of developing this app and now you want to change it. So what do you think the approach will be? You will go here and say float, or let's say all the grades are integer based. So that's the final grade. So here I will say grades. And here, obviously, I need the number of grades. And now, what do you need to do? You need to go through all the functions which are processing a student. And you need now to change all these functions which were tested, they were working, and you need to change them by adding 2 new attributes. And this is the moment when morally your developers will get like a blow. Because if you ask a developer to actually change something that he or she has developed in the last months, solving bugs, solving a lot of issues, and after that you say, hey, it's great, let's change it, because generally when you change this, it will again break. This is what every developer hates. So the productivity goes to 0. Okay, no one will, everybody will say, yeah, why haven't you said this 6 months ago? So everybody will try to figure out who's to blame. Okay, so when you change a program which works by adding new stuff and going through all those hundreds and thousands of functions and actually trying to change them, that will break the program again. And sometimes it's faster and more safe to actually rewrite the software from ground zero rather than to change it, because you will break even what you have. So in terms of productivity, companies, they need to find a better way to reuse software, because remember, change is omnipresent in software development. So we need a better way to actually take something that works and change it and you see, many times you change it not by fixing it, because we need to fix it in order to say we finish it, right? We actually change it by adding new stuff. So they needed a new paradigm of programming, because programming and C and C++ and all the programming languages are tools. Okay, so software developers are employees. They are like working in a factory. But our tools are this: the compiler, the text, and the knowledge we have. But in the end, it's a tool. So they needed a more productive tool, which will allow us to actually change existing code without actually changing it. It's like, can we take what we have and build on top of that? Could we do that? In C, we can't. So in C, you will still spend a lot of time, even if you try here to build another structure like student with grades. Okay, because you see, student with grades is not a student. So if I do here this and say, hey, I will put a student here and now I will add the grades, you still need to write a lot of code. Why? Because all the existing functions like init student, like print student will not work with student with grades because this is a different type. Okay, you can't pass a student with grades to print. So now you need to copy paste all existing functions. And now you say print student with grades and rewrite this function. So this will not work in terms of productivity. Okay. Now, another big issue with structures, and this is another story that you need to get from object-oriented programming, which means control over how others will use your attributes. So let's suppose this is the perfect function. You see, we don't validate, and this is a mistake. We should always validate here. For example, the name should have what? At least 3 characters, right? So what will happen if you pass me null here? This will break. You can't copy from null. What will happen if you pass me a negative age? So that's like a joke. Okay, you will have a student with minus 23 years and so on and so on. So here we should validate. So let's suppose you invest a lot of time here and you validate. So init student is bulletproof. We can't actually create a wrong student with wrong name, with a wrong age, like a negative age or 0 age or 1. We don't have students with only 1 year old, okay, and so on. So you spend a lot of time here. And in the end, you deliver this library to your colleagues and you say, hey, I spent 1 month to work on init student. So that data goes into the database. So it's my responsibility. Please use init student. So here you write, please, 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 100 times. You will send them 100 emails. Please use the init student. Okay. So now you have a new guy in the team, and the new guy in the middle of your project at some point will try to change, I don't know, implements a new functionality based on whatever. Each year, the student age will be increased till you pass the date of that student birth date. So it will implement this functionality. So in the end, that programmer has the power to do this. Student dot age equals minus 23 by mistake. So here you have the perfect function which will initialize a student, will validate this, but at any moment I can ignore your please use this and your emails because I can write this directly. So they will write this directly. Why? Because it's much more faster to write student.age equals a value rather than say init student brackets value age and blah blah. This is faster and they will use this. So do you have any control over your colleagues? Can you stop them on directly changing the age of a student to any value that they, I don't know, want? No. You have zero control. So how do we reuse code in production? How can we build on top of this solution with minimum effort? How can we prevent our colleagues to set direct values to some attributes for which we provide methods which validate? In C, you can't. So they came up with a new paradigm, which is the object-oriented paradigm. And the only difference is that instead of struct, now we are writing a class. So class, let's say super student. Okay. And here in the super student, I will just copy paste the attributes. Okay. And you see, at this point, you may say, yeah, it's the same. Yeah, it's the same. It's actually the same. So defining a class is like defining a structure, but instead of struct, you write class. So let me show you the big difference, the first difference. Remember, it's about control, and this will be about the entire semester. So many things that we will learn how to do will be presented in order to give you the tools to make your colleagues write code in the way you want. You don't need to send them emails. And that's why at the exam, I will design the subject. So you will have only one way to do it. I don't need to ask you because you will can't. I will give you an abstract class. I will give you an interface. I will say, hey, don't provide the default constructor. And all those small details at the beginning when you define the class will actually guide you through the only way that I want for you to implement that source code, because there is no other way. And this is object oriented. Okay. And let me show you the proof of that. So you see, at this point, you may say, hey, structures are like classes. Yes. So how can we initialize an object? So right now we call them objects. So let's say objects. Remember, for structures, they are called articles. Now we will use only objects because we will not use structures again. So I will do this. Super student. So at this point, you may say, hey, it's the same. Yeah, it's the same. You see, this is the way we created a student article. This is the way we are creating a student object. Now, let's try to do this. You see, I'm not even initialize it. Let's just go for this one. Let's see if here it's different. So super student dot, and yeah, the IntelliSense is not saying anything. And sometimes Visual Studio IntelliSense is not quite working. So sometimes you will have doubts. You may say, hey, it's not me to blame. The IntelliSense is not working. So you will actually write this minus 23. Okay. What's this? These are new types of errors, which are specific to object-oriented. You see, member super student age declared at line 6 is inaccessible. So wait a minute. So if you define a class and I want to use it, I can't directly access the attributes. No, you can't. You see the control? So this is not like with structures. No, it's quite the opposite. You have full control. So the owner of the class is the person which defines the class, and it has a lot of control over others, which means other programmers which will try to use that type, the super student. So you see, by default doesn't work. Why? Why is this not working? Because not working in object oriented, we have this tool which is called access specifier, which means we have the power. So now we are the owners of this. We are defining the class. We have the power to say what will happen with this class. So we have this tool which does not exist in Struct, or exists, but is by default, let's say public, which is called access specifiers. And they look like this. By default, if you don't write anything, the compiler, every time you define a class, will add this label here, which is called a private, which means everything which follows this label till the end of class is private. And that's why here the compiler says this is inaccessible, which means you can't access it directly. And the opposite of private, which is actually by default for structures, but for structures that doesn't exist, is public. So if I want to make the class to behave like a structure, then it's my job to write public, because you get a private by default. And now the class is publicly accessible to anyone from here. So you see, now I can do this. So you may say, why we should do this? That's a good question. Why we should do this? Why to lose the power? So by default, we will always accept the private. Remember, even if you don't write it here, you get it by default. You have seen the error. Okay. And generally, we will decide, but we will think twice before deciding what we should make public. So for example, I will say, hey, if you want to change the age of the class, then I will provide you a method which will allow you to change the age here. Or maybe you have some attributes which you may say, hey, this attribute can be changed from outside. So you have private, public, and now the scholarship is public, which means if I go here, I can't do this. It's still inaccessible. But for super student, okay, I can write his scholarship, you see, equals true. So for this one, I can still do that. Again, you may say, yeah, but why would you do that? Why do you renounce to that power? So generally, and this is the philosophy, and we will continue next week, we will actually make all the attributes private. And after that, we will define methods by which we can control how others can read or write private area. And this concept that all your class attributes are private by default. So even if I don't write this, they are private. This is called encapsulation. Okay. And this is one of the first words that we need to understand, encapsulation. And we will talk about encapsulation through the entire semester. Okay. So from this perspective, classes are like structures, are collections of attributes, and you will see functions. Okay, but the idea is that we have a new language with some interesting properties, which will allow us to reuse code. And this is inheritance. This is what we will do in the second half of the semester. And secondly, to have full control over how others will use our objects. Okay, and this is the entire semester. Okay, so this is for today. Next week, we will cover constructors